Welcome back to the deep dive. So you've probably seen them everywhere, right? These percussive therapy devices, Theraguns, and the like.
Oh, absolutely. They've really exploded onto the scene. Pro athletes, gyms, even just regular folks using them at home.
Exactly. And they promise all sorts of benefits for recovery, performance. But have you ever stopped to think beyond that immediate feeling, what's actually happening physiologically?
Right. What's going on under the skin? That's the big question.
Okay, let's unpack this then. Today, we're diving into a fascinating new observational study. It specifically looked at the physiological effects when you use a Theragun locally, specifically in healthy female participants. Our mission today is really to get past the hype and, understand the actual science.
And that's spot on, because this study is, well, it's pretty critical. We hear a lot about the clinical effects, better range of motion, maybe less pain, but the actual underlying mechanisms, what's really happening at the tissue level, honestly, the research there has been a bit scarce.
Scarce? Okay.
Yeah, so this study really aims to start filling that gap.
Okay, here's where it gets really interesting for me. This study asked a very specific question. What exactly changes locally, right? In skin temperature, deep tissue blood flow, and muscle oxygenation after just a standard, short, 4-minute Theragun session?
Yeah, a really focused question. And to answer it, they recruited 26 healthy young women. Average age was around 22 and a half.
And focusing just on women, is that significant?
It is, actually, for a couple of reasons. Historically, women have been underrepresented in a lot of biological research, which is a problem. Plus, there can be real physiological differences between sexes in how bodies respond. So it's good to isolate variables sometimes.
Makes sense. Okay, so how did they actually do the treatment?
It was very standardized. They used the Theragun G3 Pro, set to 29 hertz for exactly 4 minutes. And the target was the vastus medialis muscle. That's, a big part of your thigh muscle.
Right.
The way they applied it was specific, too. 2 minutes, moving it horizontally across the muzzle, then 2 minutes vertically. And this is important. They didn't add any extra pressure, just the weight of the device itself.
No pushing down hard, just letting it work. Got it. And the measurements, what were they looking at?
3 key things. First, skin temperature. Key skin, measured with an infrared camera. You could literally see the heat changes.
Wow.
Second, deep tissue blood flow. They used a high-power laser Doppler monitor for this, looking at both the overall flow, or flux, and the speed of the red blood cells moving down there.
Deep tissue. Okay, so not just superficial.
Exactly. And third, muscle oxygenation SMO2, using near-infrared spectroscopy, NIRS. That tells you how much oxygen your muscle tissue is actually getting. And they took these readings at baseline, before starting, then again immediately after, and then every 5 minutes for up to 50 minutes after the treatment stopped.
50 minutes? That's quite a while.
Yeah, they wanted to see how long any effects lasted. And they also measured skin temp on the other leg, the one not treated, as a control.
Okay, that's a pretty thorough setup. So after all that, what did they actually find? Was there a difference?
Oh yeah, big time. The overall takeaway: significant positive changes across the board. Pretty much immediately, and they lasted.
Okay, give us the specifics. Skin temperature first.
Right. Skin temp in the treated leg shot up significantly compared to baseline. At all the time points they measured, it actually peaked really quickly, just 5 minutes after they finished the treatment. The average increase was almost 4 degrees Celsius, 3.76 to be precise.
4 degrees, it's a lot.
It is, but here's something else interesting. The control leg, the one that wasn't treated, its skin temperature also went up.
Really? Why would that happen?
We'll get into the why in a bit, but yeah, not as much. It peaked at about 0.64 degrees Celsius increase around 30 minutes post-treatment, but it definitely increased.
Okay, what about deeper down, the blood flow?
That was even faster. Both the speed of red blood cells and the overall blood flow, the flux, peaked immediately after they stopped the application, like right at time 0 post-treatment.
Wow, instant effect.
Pretty much. The speed change was about plus 23.79 arbitrary units, and the flux change was plus 115.66. The exact numbers aren't as important as the fact that these were really substantial increases.
Okay.
And the kicker: these increases in deep blood flow stayed significantly elevated for the entire 50-minute observation period.
For nearly an hour. That's impressive.
It really is.
Yeah.
And then muscle oxygenation, the SMO2, that followed a similar pattern to skin temp. It reached its highest point 5 minutes after treatment, with a mean change of about plus 5.78%.
Okay.
And just like the blood flow, it stayed significantly higher than baseline for the full 50 minutes, too.
So let me summarize this. A simple 4-minute Theragun application leads to rapid, significant, and sustained increases in skin temperature, deep blood flow, and muscle oxygenation in the treated area. It's not just on the surface.
Precisely. It clearly impacts skin, subcutaneous tissue, and the muscle itself.
So given how quickly things like blood flow peaked, does that suggest anything about, say, when you might want to use it before activity?
That's getting into the practical application. And yeah, the timing of the peaks is definitely suggestive.
Oh.
But first, let's talk about why this might be happening. What are the mechanisms?
Right, the why. What does the study suggest?
Okay, so for the skin temperature increase, it's likely a lot like traditional massage, basically, mechanical effects. The friction from the device head moving over the skin generates localized heat. That heat increases microcirculation right there in the skin.
Makes sense. Friction equals heat.
Exactly. And that process seems to trigger the release of local mediators, things like histamine and prostaglandins. These are signaling molecules that cause vasodilation widening of the blood vessels near the surface.
Histamine. Isn't that involved in allergic reactions?
It is, but it does lots of other things too, including regulating local blood flow. And remember that blotchy redness they saw in the infrared images?
Yeah.
That's a classic visual sign of histamine release causing vasodilation near the skin surface.
Ah, okay. That connects. But what about the other leg getting warmer, the control leg?
Right, that's fascinating. That's likely a systemic thermoregulatory response. Basically, the heat stimulus in the treated leg activates thermosensors. Those sensors send signals up to the brain, and the brain responds by trying to regulate overall body temperature, partly by triggering some vasodilation in both limbs, treated and untreated. It's your body trying to maintain balance.
Wow, the body's complex. Okay, so that's skin temp. What about the deeper stuff, the increased blood flow and oxygenation in the muscle?
This is where the study points to something called shear stress as probably the primary mechanism.
Shear stress. Like friction again.
Sort of, but think of it happening on the inside walls of the deeper blood vessels. The pressure and, importantly, the vibration from the Theragun create this gentle mechanical stress, the shear stress. And this stress acts as a signal. It prompts the cells lining those blood vessels, the endothelial cells, to release vasoactive substances. Again, things like histamine, but also bradykinin and others.
And these substances make the blood vessels, what, relax?
Exactly. They cause vasodilation. The vessels widen, allowing more blood to flow through.
Mm.
More blood flow means more oxygen delivery to the muscle tissue.
Okay, so vibration leads to shear stress, which releases chemicals, which widens vessels, which boosts flow and oxygen.
That's the proposed pathway,
Yeah.
yeah. And there's other evidence supporting the role of histamine here. Another study by Needs and colleagues actually found that if you gave people an antihistamine medication before percussive therapy,
Let me guess, the blood flow increase wasn't as big.
you got it. It significantly blunted the effect, which really points a finger at histamine being a key player in this response.
Interesting. Are there any other potential mechanisms involved?
Well, another possibility they mentioned is the tonic vibration reflex, or TVR.
TVR.
Yeah. Mechanical vibration, like from the Theragun, can stimulate specialized sensors within the muscle called muscle spindles. This stimulation can cause tiny involuntary muscle contractions. Think of it like your muscle subtly reacting to the vibration. These small rhythmic contractions increase the muscle's metabolic demand. It needs a bit more energy, more oxygen. And just like with exercise, increased metabolic demand signals the body to increase blood flow to meet that need. So vasodilation happens.
So it could be sheer stress-releasing chemicals or these tiny vibration-induced contractions needing more oxygen, or maybe both.
It's very likely a combination of factors contributing to the overall effect.
This also helps explain something you mentioned earlier, right? Why this localized vibration might work differently than, say, whole-body vibration plates.
Exactly. With whole body vibration, the vibration usually comes through the feet. It's not applied directly over the specific muscle, belly, or tendon like the Theragun is. So you likely get less of that direct shear stress on the vessels within the target muscle and maybe less release of those key vasoactive substances right where you want them. That could explain why some WBV studies haven't shown the same kind of increase in muscle oxygenation.
Right. The localized application seems key here. Now, this study sounds promising, but you mentioned limitations earlier. What are the important caveats we need to keep in mind?
Yeah, definitely important. Firstly, as we discussed, it was only female participants. We can't automatically assume the results would be identical in males. Body composition differences, hormonal factors, maybe even vascular control mechanisms could potentially lead to different responses.
Okay, so need studies on men too? What else?
They didn't collect any subjective data. Like, how did the treatment feel? Was it comfortable? Did participants notice the warmth? We don't have that information on thermal sensation or comfort levels.
That would be interesting to know. Yeah.
And while they didn't report any negative side effects in this short-term study, they also didn't investigate potential long-term effects. For example, repeated intense mechanical stress potentially cause any damage to red blood cells, erythrocytes. It's something to consider for long-term heavy users, perhaps.
Fair points. So, based on this study and its limitations, what are the big questions for future research? Where do we go from here?
Well, the most crucial question, I think, is, do these physiological changes, the increased blood flow and oxygenation, actually translate into measurable improvements in athletic performance or faster recovery?
Right. We see the changes, but do they matter functionally?
Exactly.
Okay.
We need studies that connect these physiological findings to actual outcomes.
Mm-hmm.
Another big one is duration. How long do these effects really last beyond the 50 minutes they observed? Is it hours, a day? We don't know yet.
Mm-hmm.
And then there's the whole area of application technique. This study used one specific protocol, 29 hertz, 4 minutes, horizontal then vertical, no added pressure. But what about different frequencies, different durations, different device heads? Does side alternating vibration work differently than vertical? How do you tailor the application depending on whether your goal is warm-up versus recovery? Lots to explore there.
Definitely sounds like there's a lot more to learn to really optimize how these are used.
For sure.
Okay, so let's bring this all together for the listener. What does this all mean for you if you own or use a Theragun?
Well, the core finding is pretty clear. Even a short 4-minute localized session with a device like this does significantly impact your tissues quite deeply. It measurably boosts blood flow and muscle oxygenation. It's not just a surface level feeling.
Right.
So if we connect this to the bigger picture, these findings really do provide some solid physiological rationale supporting the use of percussive therapy. It suggests a mechanism-enhanced blood flow and oxygenation that could genuinely help with optimizing performance or aiding recovery.
And you mentioned timing earlier, based on when those peaks happened, especially for oxygenation?
Right, the SMO2 peaked at 5 minutes post-treatment. The study authors actually suggest, based on their findings, that applying the Theragun maybe around 10 minutes before activity could potentially maximize those physiological benefits for warm-up purposes.
10 minutes before, that's a practical takeaway.
It's a suggestion based on this specific data, yeah?
Yeah.
Gives people a starting point to experiment with, perhaps.
So we've learned a lot about what's happening under the skin with these popular tools. It makes you think, doesn't it? Knowing how a seemingly simple tool can affect our internal physiology so profoundly, what other widely used tools or techniques might have these hidden mechanisms that we just haven't fully uncovered yet?
That's a great question to ponder. There's always more to learn about how our bodies respond.